Hey guys, it's Andrew here. In the last video we looked at the representational value of each of these values on a base 10 system based on their positional value. So we said that each of these positions has a positional value in the base 10 system. So if in the base 10 system we can say 10, 10, 10, and 10, right? And 10 raised to some power, right? In this first in this first decimal position, right, I keep getting ahead of myself, bit position. And the first decimal position here, 10 raised to the 0th power, makes this the ones position, right? Or the ones column, or the ones digit, right? And this is the second bit position, or 10 raised to the 10, or 10 raised to the first, not 10 raised to the 10. 10 raised to the first makes this the 10th position, right? 10 raised to the second makes this the hundredths position. 10 raised to the third makes this the thousandths position. All right, so we know what our different positional values are for this given number, or any given number for that matter. If we had, 57,633, this would be 10 raised to the 4th, as it is the 5th position, or 10 raised to the 4th, and this would be the 10,000ths column, and then the 100,000ths, and the millionth, and so on and so forth down the list. All right, so based on this information, what can we say? We have two main facts that we can actually look at. And first is the actual significance and the value of each of these digits given their positional value. All right. So 7633 doesn't really mean a whole lot to us right now. But if we say made this, this money here, right, $7,633 means a whole lot more to us. All right. And what we can see is that as we move from left to right across our number, and as we go down in towards this this ones position from the thousands position, we can see that this leftmost value here is our most significant value, right? And then this guy over here is our least significant, all right? And they're least significant in the way that we can just look at the number, right? If you had $7,000, right, or $1, or sorry, $3, my bad, $3, which is worth more, right? Would you rather have $7,000 or $3? I don't know about you, but I'm going to take the $7,000 every time, okay? So that's one thing we can look at, but we can also derive our number based on our positional values. Now this is going to look a little bit roundabout at this moment in time, but when we move into binary conversion, this will all really start to fall into place. So if we have a 7 in the thousands position, all right, so I'm going to warn you, math time, math is incoming, all right. If we have a 7 in the thousands position, if we multiply that position times this digit value, so 7 times 1,000, right? We're going to put this in parentheses. We get 7,000. And then we add that to 6 times the next position value, which is 100, all right? So 7,600, okay? So bear with me here. And then we're going to say 3. So 3 times the tens position, so 30, right? And then one more, 3 times the ones position, or 3 times 1, which is 3. Or altogether, we're going to get 7,633. Okay? Now, kind of a roundabout way of looking at this, but we can take this position here and directly attribute it to the thousands position, and the digit that's going to represent it is the 7, all right? And then the 6 to the 100, okay, 6 to the 100, the 3 to the 10, and then the 3 to the ones position. We could do the same thing again for a different number. So let's take the number, I don't know, so I'm actually going to clean this up, and we will come back and we'll do another example. So let's take a look at another number, right? So let's take 5 and I'm actually going to spread these out a little bit here. 5, 0, 4, 2, right? 5,042. All right, we got this 0 in here. Let's see how this affects it, right? Does this actually do anything, right? So this guy here, this 5 is in the tens position, or sorry, we'll go through the positions here. So 10 raised to the 0th power is 1, 10 raised to the 1st power is 10, 10 raised to the 2nd power is 100, and 10 raised to the 3rd power is, 1,000. Okay, if I can write a 0. All right, so, 5, and then we can take these guys and we can work backwards based on these positional values and actually rederive the number, if you will. So we can say 5 times 1,000, all right, plus 0 times 100 plus 4 times 10 plus 2 times 1, right? And that's going to give us our 5,042. Now, keep in mind, even though that this is a 0, that position is still significant, right? Because if we dropped it out, right, when we got rid of this guy, our number would be 542, no longer 5,042, all right? But we do have to be mindful of this 0 position. Now, there is a catch here, and instead, if we actually swapped these two guys here, right? So let me just clean this up here a little bit. So let's say we swapped these guys, and we made this 0 and 5, okay? And we went through this process all over again, all right? And then we said 0 times 1,000, okay? And then 5 times 100, plus 4 times, that's a 4, I swear, times 10, and 2 times 1 equals 0,542. Or you could actually drop this leading 0 and then just make it 542. All right, 542. So unless we have a leading 0, that leading 0 is not going to significantly affect the rest of our number. But if we have any zeros riddled in between our numbers anywhere, those are going to, if we remove those zeros, it would negatively affect the value of the number. So you do have to be mindful of the position of the 0, but if the 0 is leading the entire number, we could drop it. So if we had some zeros out here, right, this number is still 542. But if we, if we take one of these and we get rid of this, and we put a 1 here, well, it's now 100,542. So the position of a value other than 0 in relation to 0 somewhere in the number can either negatively or could negatively affect it if we dropped any zeros. So just be mindful of that. But you will see as we start to look into our binary system of zeros and ones, if we have a bunch of zeros out in front of our number here, right, these zeros, they're not going to really affect the total outcome of the number, okay? So now that we have a basic understanding, let's just recap the rules here, right? We have a base 10 system, and again, that base 10 system is 0 through 9, right? It's a 0 through 9 system, 10 total values, all right? And each of those total values has a positional argument, positional value for a given number at each digit in that number. All right, so in the number 7,000 in 7633, right, 7633, this last 3 down here all the way to the right is our least significant number, and it's in the ones position, where the 7 is all the way over here to the thousands place, and it's our most significant value, and so on and so forth, thousands, hundreds, tens, and ones column, all right? And if we had our 5 and our 0 flipped here, right, our number is 5,042, right? And, we can derive that 5,042 by each of the positional locations and multiplying it by their given values. And we're going to use this exact same concept of being able to take the positional argument of either a 0 or a 1 in a given position and derive the decimal value from it. All right. So in the next video, we're actually going to start looking at moving away from the base 10 system and moving into that base 2 binary system. And we're going to build a binary number line, and then we're going to be able to, given our different values of either 0 or 1, we're going to derive, based on their positional argument, their positional notation, what the decimal value is. So stay tuned, and we'll see that coming up in the next video.